Go on to this one. 5C. So we're going to be learning now matrix equality, addition and subtraction. So basically just adding and subtracting your matrices. Okay. Matrix A and B are equal. Okay, so this is something that you got to think about when it comes to adding and subtracting matrices. Some of the things have to be equal or the same. Okay. One thing is they need to have the same order when you add a matrix. What does that mean? Same order. Same rows, same columns. Okay, they have to have the same rows, same columns. Okay, and they also have the same elements. Although this is not necessarily important when it comes to adding them, but they are equal when they have this. Basically, matrix A and B the same when they are equal. That everything about the matrix is the same. Okay, so the number of rows and columns are the same, and the numbers in them, so the elements are also the same. Okay. So it has to be basically identical. Now, if you look at this example down here, find the values of x and y if. So if these are equal. Okay. So if this is equal, what is the value of x and y? So if they're supposedly the same, x is going to be good, and y is going to be -1. Okay, so they're exactly the same matrix. Also, same number of rows and columns. Okay, same order. Alright, this one's a bit trickier. Okay, if they're identical. Okay, if they're supposedly identical. So 0, 0, 3, 3. That's 1, -2, -2. What is y for starters? Yeah, it's tricky. But y, let's start with y. What's y going to be? 5. No, oh, actually 7. So that's 7 minus, yeah, not bad. Okay, 7. Because this element should equal 5. Now, if this equals 4, 2x, what is x going to be? 2, because 2 times 2 is 4. Okay? So, understand that when you're looking at adding elements, okay, you have to look at the same one. So, if you want to add 2, you have to add it with this 2 here. If you want to add this one, you have to look at the same element for it, okay? When it comes to adding and subtracting. Okay, you got to look at the elements and put them together. Okay. For each of the following, give reasons why they're not the same. So why are they not the same now? Even though this is a row matrix, that's a column matrix. Remember, one of the rules first is they have to have the same order. So what's the order for this? This is a 1 by 2. This is a 2 by 1. So can you add them together? No, because they're not the same order. So
what do you just say? What do you want?
Order is not the same. Okay, that's order is not the same. Okay, that means you can't add them together, and they're not exactly the same matrix. So, the question is saying, give reasons why they don't equal each other, why they're not the same. Okay, so B, why are these ones not the same? Well, you can see 4 and 4 are the same, 0 and 0 are the same, but then you've got this element, that element, they're different. Okay, so you could say element A, row 2, column 1, and element B, row 2, column 1, are not the same. Yeah, well, all you're doing here is you're trying to prove that they're the same matrix, basically. Okay? Yep, so I'm just saying here, why aren't these equal? Why aren't they the same? When you're adding them, you just need to have the same order, but you don't necessarily have to have the same numbers. Okay, but what this example is showing here is why aren't they exactly the same matrix? So you're just saying that this element, that element are not the same, that element and that element are not the same. The question is, why aren't they the same? It's because this one, so that's row 2, column 1 of A, row 2, column 1 of B, not the same. Okay? Alright. Is anyone confused about that? Not really? Okay, good. Okay. Now we get to the main part of adding and subtracting. Okay, so if you look at this little sentence here, A plus B and A minus B are only defined, which means they can only work if they have the same order. So like I said before, you can only add or subtract the matrix if the order is the same. Okay, so to add or subtract, the idea is it's basically adding and subtracting the corresponding numbers. So to add or subtract matrices, or add or subtract the corresponding elements or the numbers. If a matrix is a zero matrix, which means all the elements are zero, okay, this is just saying that m plus z, okay, which is a zero matrix, and m minus z are the same. Okay, they're all exactly the same. So let's actually just get into some examples instead of looking at the words. So if A is this matrix and B is this matrix, let's figure out what A plus B is. Okay, so let's start with that.
So we added all of these together?
Yes, now we start adding. So let's do this. Part A. A plus B. Okay, so this is how I want you to show this when you do your working out for it. Okay, so I would go matrix A. I can't see it. Sorry, guys. So matrix A plus matrix B. So A plus B. That would be 2, 3, 0, 1, 4, 2 plus B matrix right there. So 1, 2, 3, 2 minus 2, and then 1. Okay, so in order to add them, you have to have the same order, row and column for each one. Because if it's not, then some of the numbers won't work out. So adding these together. Okay, so this is matrix A, matrix B. If you want to be really neat, I would write it like this as well. If you just want to be A, it should be technically A plus B. Okay, if you want to be that neat, A plus B. So adding them together, you've got, remember for this you have to add the elements with one another. Okay, so you can't go 2 plus that 2, for example. You can't go that plus that. You've got to add them all in the same spot. So it's going to be 2 plus 1, so that'll be 3. 3 plus 2, so this element or that element, so 5. And then you've got 0 plus 3, which is 3. 1 plus 2, so that's 2. 4 plus negative 2 becomes 2. And then 2 plus 1 is 3. So that means A plus B together is there. No, just adding the matrices together. Now part B. Okay, is going to be B take away A. Okay, so it's B minus A this time. Okay, so B minus A. So that's matrix B, that's matrix A. So we're just going to go 1, 2, 3, and then 2, negative 2, 1. Take away matrix A, which is 2, 3, 0, 1, 4, 2. Okay, so now you're just minusing them based on their location. So it's going to be 1 minus 2, negative 1. 2 take away 3, also negative 1. 3 take away 0 is 3. 2 minus 1 is 1. Negative 2 minus 4, negative 6. 1 minus 2 is 3. Oh, sorry, negative 1. Negative 1. Okay, so that's B minus A. A minus B, so the other way around now. Okay? A take away B. Okay, so this is matrix A, that's matrix B. So it's A take away B. So the other way around. Alright, so that's 2, 3, 0, 1, 4, 2. Take away matrix B, which is this 1, 2, 3, 2, negative 2, 1. What does that equal? Okay, so 2 minus 1 is 1. 3 minus 2 is also 1. 0 minus 3 is negative 3. 1 minus 2, negative 1. 4 minus negative 2, tricky. 6. It becomes plus. So it becomes plus 2, which is 6. Okay, 2 minus 1 is 1. Okay, and then the last one there is saying write down a zero matrix Z so that when you go A plus Z, it still equals A. So it's just basically saying everything plus 0. So as a matrix, what you'll do, okay, for D, so the question is saying write down matrix Z. So what's matrix Z going to be? So that A is going to be A again. So you want
0, 0, 0, 0, 0.
Yeah, so it's basically what you want is A plus Z, and you want it to be equal A. Sorry, you want it to equal A. So that's asking what is matrix Z going to be? Okay, so in this case, A, is this matrix 2, 3, 0, 1, 4, 2 plus what is matrix Z going to be so that it equals
0, 0, 0, 0.
2, 3, 0, 1, 4, 2. And as Joseph said, it's just going to be all zeros. And that's it. Okay? So matrix Z must be all 0. 0 matrix.
So what's D?
D. This is just saying, write down a matrix called Z, where if you add A with Z, it still equals A. So just saying, make a Z a 0 matrix.
So D equals A.
Yeah. No, A plus Z equals A.
And Z means just 0.
Okay. Okay, last bit, and then I think the rest of this will probably be homework for you guys. Okay, so let's just finish this off. I'll put this recording up on YouTube. You guys can watch it at home if you want it. Okay? So some application questions. The number of students at 2 different schools studying VCE in 2019 and 2020 is shown here. Okay, so these are what they're studying for maths last year, the year before that, and the year before that this year. So this is actual data from our school and another school. I won't tell you which school is which though. Okay, so our school and another school. I don't know. I can't tell you that. Construct 2 matrices X and Y from this information where they each represent a number of students at a math subject for that year. So what you're going to do is, because you have 2 years, okay, we need to represent this into 2 matrices, okay, for the year, depending on the year. So 2019 and then 2020. Okay, so let's make a 2019 matrix and a 2020 matrix.
This is for 5C, like that.
Okay, so this is going to be the 2019. And if you have a look at the matrix, guys, so let's look at this information first. How many rows, how many columns?
3 rows, 3 columns.
2 rows, 3 columns. So 2 by 3. Okay, so this is going to be a 2 by 3. Alright, so you've got 142, 64, and 19. And this is 134, 42, and then 8. Okay, so that's that matrix. Let's do it like this. Oops. Oops. Can I move this around? Nope. Okay, wait, let me move it. I'm just going to move, I wanted to try and move this a bit closer, but that's alright. So 2019 is this matrix. I'll just do this. And you want to make sure you write again some of the elements in it. So, as in what the row and what the columns mean. Okay, so this is school A, this is school B. Let's use another color so you don't confused. Okay, so this is school A, that's school B, so that's that row, that's that row. And then what are the columns? So this is further maths, I'm just going to write FM, further maths. Methods, we'll just go MM for maths methods. And then specialist, we'll go SM. So this is the 2019, these are the numbers and the elements for the schools, A and B, and what each student studied depending on the subject. Yeah, call it X. Yeah, let's call it X because it does say in the question. Construct matrix X, matrix Y.
You always make the first one X.
Depends on the question. Yeah, it'll change. Okay, that's X. Okay, so for the other ones, 2020. And we'll call this one Y. Okay, same information, similar information. Used. So for 2020, 2 by 3. Okay, so you've got 150, 60, and 20. And you've got 120, 50, and then 10. So again, similar information in terms of the row and column. This is school A, school B. Further maths, maths methods, and specialists. Okay, so there's our matrices. Alright, part B is now we're going to find and interpret X plus Y. Okay, so if what this is saying is you're going to add X and Y matrix together. Okay, so X plus Y. So you're going to find and interpret what does X plus Y mean. So 142, 64, 19, 134, 42, and 8. Plus Y, which is 150, 60, 20, 120, 50, and then 10. Okay, so find and interpret this. So when you add these together, remember you're adding the same elements. Okay, depending on what matrix, what the order in that is. Alright, so this should be 292. This should be 124. This should be 39. 134, that'll be 254. That'll be 92. And that'll be 18. Okay, shh, listening guys. So in terms of interpreting, what does this matrix mean? If you added all of the numbers together, okay, just in the context here. Anyone know? So you would write matrix X and Y, or matrix X plus Y represents the total number of students in both schools and year levels and year that studied all math subjects. Okay, so that's the total. Now, without going into the working out for the next one, what would you do if you did Y minus X? So if you did this matrix minus that matrix, what would that be? What would that represent?
Difference.
The difference in? Yeah, but not just in years. Difference in number of that studied compared between 2019 and 2020. So if you minus that, that's what the information would represent. All right, so I'm going to stop there.